Good afternoon everyone and welcome to the Voltimum webinar series. My name is Christian Kiss. I'm one of the product managers from OSRAM Australia, and I'll be your presenter for today's topic on the LED lighting essentials. If you have any questions, please use the chat box on the left hand side and they'll be answered during the webinar. Okay, so this is just the agenda or overview of what we'll be covering today. So we'll go through some of the basics on the LED products. So what is an LED? How does it produce light? We'll talk about light output and how it's expressed. Then we'll go on to drivers, power supplies, do's and don'ts, little things that are critical for obviously getting LED products correctly matched up to the right power supplies. We'll talk about dimming, some common lighting terms, and then go on to a bit of LED product examples and so on. So what is an LED? So in its basic form, an LED is a semiconductor device that emits a narrow spectrum of light as soon as direct electrical current is applied. So every LED has two layers. There's a N-doped layer and a P-doped layer, and what happens is as you pass current through the product, through the LED itself, the chip, the electrons pass through from the N layer and find holes in the P layer, and as they find these holes, a photon is released and hence light is produced. Sorry, just had there we go, bit of a slide issue there. So after manufacturing the LED die and assembling it into an LED component, or a package as some people call it, we now go about producing light. So generating white light can be achieved in a number of ways, the most common of which is either using RGB, which is red, blue and green LEDs, and color mixing, or using the additive color system by adding colors and mixing, or phosphor conversion. So color mixing and phosphor conversion. So one of the most common ways to produce LEDs is to use a blue LED chip and basically use phosphor on top of it to create white light. That's actually not very uncommon in the way that it works from traditional technologies. So we've been doing phosphor conversion with fluorescent lamps, for example, for quite a number of years. So it works on a similar principle. And by changing the actual phosphor coating and the thickness of the phosphor and the types of phosphor mix within the actual LED chip package, you can control the actual color temperature of the LED, so whether it's a cool color or a warm color and so on. So phosphor conversion can be achieved in a number of ways, and the most common of which are these three versions here, which are called either volume conversion, chip level conversion, or remote phosphor conversion. So a bit of pros and cons on each type. With the chip level conversion and the volume conversion, they're more or less a similar principle. With the chip level conversion and the volume conversion, basically it's the most mature technology around at the moment, so that's one of the advantages. It's relatively low cost to manufacture LED chips in this way. It's a point light source, so it's very easy to control the light with optics, reflectors, lenses and so forth. Some of the cons of this method is typically you get cooler color temperatures with this method. Hence, if you want to get a warmer color, you need to add extra phosphor, which can reduce the output of the LED and therefore the efficiency. You cannot do things like color temperature tuning, so color temperature tuning, dynamic white type light in this sort of method. Remote phosphor, some of the pros on that one are there's less glare because you've got a flat surface phosphor, which is not a small point source, so the glare is not as high, it's minimized. The phosphor tends to last longer because it's not directly on the actual chip itself. Some of the cons though, it's a larger package, so it's a larger size LED engine or chip package, which is sometimes impractical, and you do get a slight reduction in the efficacy with this method. So in the way of color temperatures, which I touched upon just a moment ago, there's many different types of white light, as most of you should already be familiar with, and the way we express color temperature is called correlated color temperature. It's expressed in degrees Kelvin. So basically when an object is heated sufficiently, it radiates a light of specific progression of colors, and it's basically compared to burning of black bodies, and that's how they've come up with the color temperatures. So in very simple terms, color temperature is just the color appearance of a light source. So it can range from a warm color like an incandescent lamp, which we would rate at 2700 Kelvin, up to 6,500 Kelvin, which we call daylight, which tends to be more on the blue side of the spectrum. So as the Kelvins get higher, the color gets more towards the blue scale, and conversely, as it gets lower, it gets more yellow or orange. So going back to a general lighting terminology, something that in the lighting industry is probably the most important term would be lumens. So lumens, or also referred to as luminous flux, is a measurement of the total amount of light emitted from a light source in any given direction. So it's based on a standard unit as perceived by the human eye, and it will tell you pretty much how bright something is. So that's just a standard measure of light. So another important term, and not specific obviously to lighting, is watts. So watts is a electrical unit of measure to measure the actual power consumption of a device or a light source, and it measures how much power is consumed. Excuse me. It's impractical to use the watts. It's impractical to use watts as the measure of light, because different technologies will have different efficiencies, and therefore one product will have a different output to another of one technology from another. For example, an incandescent lamp is a lot less efficient compared to a compact fluorescent or an LED. So lumens is a critical thing to use as a reference, because by using your lumens and looking at your power consumption, you can work out the efficacy of the product, and we call this luminous efficacy, measured as lumens per watt. So it's a simple calculation of obviously lumens divided by your power consumption. So for general consumers, an easy way to understand what lumens would be is looking at this little chart here, where you've got a 40 watt incandescent, which could be about 400 odd lumens, and a 100 watt incandescent at 1340 lumens. So quite inefficient. A 100 watt lamp is really around 13 lumens per watt, for example, in the old incandescent technology. The little chart at the bottom there just shows the progression of lighting technologies over time, and the way they've grown and matured. And basically LED, as it was introduced particularly into general lighting back in the early 2000s and late 90s even, has rapidly grown in terms of efficiencies. In each year there's efficiency gains and also cost reductions over time, so it's become a product that's continuing to evolve over time and will continue to do so. So going back to another lighting terminology that's used in some cases, the unit measure of candela is basically an intensity of light in a given direction. So this is normally used for reflector lamps, for example, your dichroic halogens, where you've got a specific beam angle. The beam angle will designate the width of the beam and how intense the light source is. So while it's a good indication of when you're comparing one reflector lamp to another, it's not a good measure to actually measure how efficient a product is. It's always better to use lumens as a total light output. Okay, so color rendering, another lighting term. As a rule, artificial light is always, artificial lights as is perceived by the human eyes have different spectrum of light output, and basically the actual spectral distribution will determine how well colors are perceived to the human eye. So a certain light source may have a certain emphasis on the red end of the spectrum, another light source may have more on the UV side of the spectrum. So effectively the color rendering, which is also represented as RA, is a measure of the correspondence between the color of an object and its appearance under a reference light source. So to determine these values, they use test colors on a color swatch, and then the average of overall is taken of that, and that's how you determine what your color rendering is. So in effect, it's a number on the scale of 1 to 10, 1 to 100, sorry, kind of like a percentage. So the higher your value, the better color rendering, because the better your eye will perceive specific colors under the light source. So a light source of 100 is a reference light source, which is an incandescent lamp, for example. So that's determined under the color rendering index to be the light source with the best color rendering, and therefore rendition of all the different parts and colors of the light spectrum itself. So some typical color rendering numbers would be 80 for fluorescent lamps and LEDs and so on. So the effects of color rendering can be seen in this image down here, for example. Color rendering of 80 compared to a color rendering of 90, where the reds and the yellows might be a bit more pronounced. You can see a visual difference there in the two, under the two different light sources. So again, this table here is just a bit of a comparison of different technologies and how different products perform. So the old fluorescent halo phosphor tubes, which are pretty much phased out now, used to only have a color rendering of 60, so things could look quite washed out, or there was many complaints a long time ago with people not liking fluorescent lights because they don't see natural colors under it. With the more common recent fluorescent technology, the tri-phosphor tubes, which use 3 different types of phosphors, the color rendering's naturally a lot better, and therefore you don't really have these same issues anymore. So color rendering is important based on the application that the light source is being used in. For example, in a retail store, you would want to showcase your merchandise with very bright colors to attract your customers. So in that case, you would look for something with a very high color rendering of 80 or even 90 plus. There's something like street lighting, where all you really need to see are moving objects, which are vehicles and people. A sodium lamp would be sufficient where the color rendering is quite low. So light output and how is it expressed? So it's important to understand that with traditional lighting fixtures, the way that the actual light output was expressed is quite different to an LED fixture. And there's two methods of lighting methods here. So one of them is called relative photometry, and there's the other that's called absolute photometry. So what are the actual differences? Well, we'll see it here. So in this example here, there's an LED high bay fixture which has a lumen output of 23,000, or rounded up to 24,000 lumens, thereabouts, at 230 watts. So that's absolute light output there, because that's the light output coming out of the light source. So that's measured at the through the lens. So it's not at the chip level or the light source. It's the complete luminaire. So it's called absolute photometry when it's measured as a complete luminaire. In the case where we compare it to a high intensity discharge lamp, for example, a 400 watt metal halide, which has 35,000 lumens, with a fixture which has a light output ratio of 0.66, we use relative photometry normally for this sort of calculation. So basically you take into account your light output from the light source itself, and you multiply by the actual light output ratio from the luminaire or the fixture itself, and therefore when you do that, you end up with 23,000 100 lumens in this case here. So that's what we call relative photometry, which is important when you're considering different light sources, because with LED luminaires as a finished good as such, we no longer use relative photometry there. It's absolute photometry, so it's measured the light output through the lens of the actual fitting itself, and that's the lumen output that's quoted. So something to be aware of here is that sometimes the lumen output claims from certain suppliers can be questionable. Sometimes it has been known that some suppliers, for example, would be quoting the lumen output through the chip and therefore not factoring in any losses through either optical lenses or reflectors and so on and so forth. All the reputable manufacturers should normally be quoting the absolute photometry from an LED luminaire. Okay, so moving away from that side of things, we'll go on to some of the do's and don'ts of power supplies. Oh, we've got a question here. So the question is, what about the output angle? So I'm not quite clear what that is in reference to, so we'll come back to that at the end perhaps. Because if we're talking about the relative and the absolute photometry, we're just talking about the total light output, so that's not factoring in the angle or anything. That's just the total light output of the luminaire that I was referring to there. If we're talking about a specific angle again, we'd probably be measuring candelas for the light source to measure some intensities, if that's something that's important for a spotlight, for example. Okay, so LED drivers and power supplies, do's and don'ts. As mentioned earlier in the slide, LEDs are a DC light source, so they're direct current driven, meaning that current can only flow one direction. So it's important to make sure that we got the right power supplies or drivers to go with the product that you want to operate there. So some of the do's, it's always an important and pretty obvious one to consult the manufacturer regarding the transformers or drivers that are best suited to the LEDs being used. If dimming is required, then consult the manufacturer for suitable dimmers. So going for those 2 points there, the reason why that's important, particularly with the LED lamps or retrofit type products, which are designed to work on existing technologies such as halogen transformers and so forth, where you're just replacing a halogen lamp and putting an LED retrofit type lamp on there. You have to make sure that the actual transformer is capable of operating the lamp without any issues. So some transformers can have issues with minimum loads. For example, a lot of them are 20 watts rated as a minimum load, so you can encounter issues where you underload your transformer, and then of course that results in no light, or sometimes you can get flickering. Dimming and compatibility with LEDs is a bit of a, I guess, a problematic thing for the lighting industry in some regards, because with a lot of the existing dimmers, which are phase dimmers in the market, they've been designed long ago for incandescent technologies and so on. So retrofitting LEDs can prove to be problematic at some time, and then there can be issues such as flickering, your lamps will blow, your dimmers can blow. So it's just always best to consult the manufacturer with their data sheets or their documents in relation to which specific models you should be using the products on. So how do we overcome flickering is a question that's been asked. So again, first question would be making sure that you're using a dimmer that's recommended by the manufacturer. If you are, then there could be potentially some other issues at hand. It could be something external, on-site site related potentially. It really depends on what product we're talking about. So if you've got flickering, another question's been asked, so without dimmers, so going back a step, so again, depending on what product we got, so flickering without dimmers again, could be an issue with transformers and compatibility. So if you're not meeting the minimum load, the transformer may be trying to start the lamp up, but it's not enough to sustain the light source being on, and then it will switch off and then it'll continue cycling through and either flicker or not work at all. So a couple of things that could help there is either changing the transformer to one that's compatible, or potentially putting on more lamps to add load to that transformer, for example. So I mean, this all drills down to the last point here, is understanding that LED lights behave differently compared to traditional lighting. So the dimming ranges and responses on your dimmers and your transformers are going to react very differently to how the traditional lighting technology is operated. So 9 times out of 10 you're never going to have an LED dim down anywhere near as low as a halogen, for example, on an MR16 halogen transformer. So I guess we have to manage these expectations by the customers and consumers and so on, in terms of what is possible and what is not, and to try and, I guess, mitigate that, we develop these documents which state the dimming compatibility, transformer compatibility, and all sorts of things, like, and application type related stuff, where we sort of, I guess, help work out how to load up a dimmer and how many lights to put on a dimmer and things like that. So some of the don'ts in the power supply side is obviously don't overload the power supply. Now when we're talking about MR16 LED type lamps specifically, which we've been talking about a fair bit at the moment, so with those type of lamps which you're putting onto a halogen transformer, one important thing is not to overload the transformer by thinking, okay, it's a 10 watt LED, I can put 5 lamps on there. Again, LEDs behave quite differently to a traditional lamp, so there's a high inrush current on LEDs, and this puts a strain on the transformer. So again, going back to the manufacturer specifics, they may say put 2 of these lamps on a transformer, or what is often the case, if you're replacing a 50 watt lamp and the lamp's designed to have similar output to a 50 watt, then treat it as a 50 watt load and basically have 1 transformer per lamp, and don't put more than that, because that can create problems. So also, as we've been talking about, don't underload the power supply, so that's to do with the minimum load of the transformer itself, so there can be erratic operation. Okay, so that's the do's and don'ts generally speaking. So dimming LEDs, which I've already touched upon anyway, so controlling the driver through dimming protocols is achieved by a variety of different methods, each with their own pros and cons. So what we've got here, so we've talked about phase cut dimming, which is basically mains dimming by chopping the waveform. So that's the incoming mains, and that's available in 2 different types of dimming technologies. So you've got leading and trailing edge dimming. You've got analog 1 to 10 volt dimming, so that's a dedicated pair of cables running to 1 to 10 volt compatible fittings or drivers. You've got DSI, digital serial interface, which is a digital version more or less of 1 to 10 volt. You've got digital multiplex, which is often used in entertainment industry for theatre lighting and things like that, but also nowadays for a lot of addressable, color changeable type facade lighting and things where it's quite dynamic. And then we've got DALI, which is digital addressable lighting interface, which is quite common for commercial installations of office buildings and things like that, where ballasts and drivers and so on and fittings themselves can individually be addressed and controlled via a control BMS system. Okay, so some common terms in lighting that get thrown around and something to be aware of and familiar with, things like L70, for example. So L70 is a reference to the lifetime of, well, it's the definition of how we define lifetime at the moment, or how the industry has gone about agreeing to define lifetime of LEDs. So it's basically when the light output has diminished to 70% of its initial lumen output, so a 30% degradation of light output. B50 was the olden days reference to any traditional technology such as filament lamps, fluorescence. Basically, it's where a sample of lamps would be operated for a certain period of time and 50% of the batch would fail. Basically, that determines what your average lifetime is, so that's what we call B50. You might see also nowadays that people talk about L70 B50. That just means the same thing as what L70 means. It means in a sample where you've got lamps on a test running and operating under their lifetime, basically L70 is achieved when 50% of the light source, 50% of the samples will have reduced or diminished light output down to 70% of its initial value. So that's what that refers to there. Okay, sorry about it. So here I've just gone to some common types of LED products, for example. So LED products are available in a few different formats and types. So what we call LED lamps are basically designed to be a lamp product. So they've got your traditional bases like your bayonets and your screw-in caps, and also G13 in the case of the LED tube type products. So some of the pros and cons for these sort of products are the pros for a retrofit type lamp. It's designed as a simple replacement lamp that can go into existing fittings without having to change or upgrade your fitting necessarily. So it's also designed in the same familiar shape that consumers and people would be familiar with, so they're not too different there, and they're designed, and you get more or less the same sort of outputs. Some of the cons with this type of product is, I mean, in comparison to traditional technology, the cost is still relatively high in comparison to the traditional fluoros and your halogen lamps and so on. However, it's becoming more and more affordable over time as prices keep eroding through the market and products become a lot more affordable. Some of the cons also include what we talked about in the previous slide. So dimmer compatibility can be limited, particularly because the loads are behaving differently to the traditional technology. So, I mean, with that, as always, make sure that the lamps are compatible with the dimmers you either have in place, or make sure that before you purchase dimmers, you purchase the correct ones for the product. We talked about this as well. For low voltage lamps, compatibility with transformers can sometimes be an issue. The last thing that I guess is a con here would be due to international standards for certain lamp types. There's sizing and weight restrictions as well. So that can restrict, in essence, the light output of some lamps, because you can only fit so much heatsink in there, for example, to draw away the heat. So how does the fitting, there's a question been asked, how does the fitting the lamp is going into, bear with me, affect its lifespan? So that's a good question there. So with a lot of these LED products, that we as a manufacturer have a recommended ambient temperature range, and also we state on a lot of these products what the maximum TC point is. So if you've got a completely confined fitting where the lamp doesn't have any ventilation or additional support from the fixture itself to draw away some heat, then potentially it can adversely affect the lifetime of the product. It depends on how hot the actual product will get. So with the higher wattage products, I would say that they're probably there'd probably be more of an issue there, because they would tend to get hotter, of course. So that's an important thing to check. For example, if you've got a 60 watt GLS style lamp in an incandescent style, it probably wouldn't be too wise to go too high on a wattage with the LED type globe. Even though you're going to get more light output and you're consuming a lot less power, it's probably safer to go with something that's equivalent, because it will have less heat, and therefore you're going to be it's going to be less likely that you'll have problems with heat management inside the fitting there. Okay, so just moving on to a few other examples of LED products. So there's also LED modules and light engines. These are basically what we call OEM or original equipment manufacturer type products. So these, a local manufacturer can easily fit into a housing and develop a fitting quite quickly for very specific project requirements. So some of the advantages of these sort of products are the customization is obviously quite high, because the fixture type is obviously limited by the capability of the OEM to build such a fitting. Modules like this typically and always will more or less have a high lumen package offering, so you can actually have a very high lumen package offering that's not available in the previous type of products in the LED retrofit style, for example. You can also custom match drivers with dimmable drivers or non-dimmable drivers depending on the application and project that they're going into. Some of the cons, obviously the cost is a little bit higher than the retrofit style products, and that's really more or less it. I mean, in terms of for project type applications, you can be quite specific and specify a type of module in a certain type of fitting, and a manufacturer will be able to design and make a fitting for that requirement with this type of product. And then I guess the final sort of variation of products that are available in the market are complete ready-made luminaires. So they're available in all sorts of shapes and sizes, so complete downlights, oyster lights, troffers, high bay fittings, you name it. So more and more of these fittings are obviously getting out in the market. Some of the pros of this is obviously with the engineering that goes into these products. You would think obviously the manufacturer has thermally managed all the critical points quite well, so the heat sinking for the LEDs themselves, the driver is an ideal match internally with the LED, so there's no need to try and match up a driver to the luminaire because it comes complete. There's obviously manufacturer-backed warranties and guarantees and things like that that they offer as a complete package for this finished good. I guess some of the cons that people bring up every now and then is if the driver fails or some chips fail for whatever reason, you have to replace the entire luminaire. You can't normally service these type of products, so that's basically one of the main cons that we hear. But otherwise, performance and engineering, these have obviously been designed to operate for certain applications depending on what the application is. So that's pretty much it from my end here. So this is just a slide on OSRAM and who OSRAM is, and globally we've got 35,000 employees, and have a presence of over 120 countries, and there's our revenue and so forth. So I guess if there's any questions, now's the time to put some in the chat box, and I'll happily answer them as best I can. Okay, thanks everyone for being online. I would like to thank you for today's viewers for tuning into the Voltamum webinar. We now have 30-second survey if you would like to participate. The survey questions will be coming up for you. Thank you very much, everyone.